Okay.
Hi, welcome to the Math Center. I'm Ravi Menon. Today, we're not going to do any serious mathematics. Today, we're going to just have a discussion on, let's say, a simple idea in physics. It's one of my very strong points. I enjoy physics quite a bit. So I thought, let's talk about physics for a change. Usually we talk about mathematics, we talk about formulas, we talk about all sorts of calculus problems and so on. So today we will talk about a simple idea in physics. Okay. We want to talk about equations of motion. Okay? Equations of motion. In physics, we study this under an area called kinematics. So we will start by talking about constant acceleration. Okay, motion with constant acceleration. Some books also refer to it as uniform acceleration. So when you have uniform acceleration, we can draw our velocity time graph. It will look something like this. Okay, so we will develop all the formulas based on a simple graph like this. Okay, when you deal with constant acceleration, we have v here, meter per second. Okay, and we have t here, our time axis, in second. So let's say our initial velocity is u, and let's say our final velocity is v, and let's say our time of travel is t seconds. Okay, again we have motion exhibiting constant acceleration, and we are looking at a velocity time graph. Note, when you deal with constant acceleration, we have a straight line graph. Okay. Now, take note of the notation. This is pretty common. When t equals to 0, we have u, the velocity, and when t equals to t, then you find that the velocity is v. To make our notation quite easy, we'll just use what is normally used in books. Okay. First thing, let's start by talking about our acceleration. Acceleration is defined as v minus u over t. Okay? The change in your velocity divided by your time. Okay. Then, the displacement, or let's just call it distance traveled. Okay? Because we are looking at motion where direction does not change, so whether we use distance or displacement, it doesn't matter. So I'm just going to use displacement and distance interchangeably. So let's just say S is our distance traveled, and S will be given by the area beneath the graph. Okay, the area beneath the graph, and that will be the area of a trapezium. So I can write u plus v over 2 times t. Okay, the area of the trapezium, we have u, and then we have v, and u plus v over 2 multiplied by your height, which is t. Okay, we're done with that. So let me just circle this. This is by definition the acceleration. This is the displacement. And now let's play around with these formulas. Now let's start here. S equals to u plus v over 2 times t. Now from here we can write v equals to u plus at. So now let's substitute u plus at over 2 times t. So this becomes 2u plus at over 2 times t. So when you sort the algebra out, you will get the third formula that we normally use when we deal with equations of motion. S equals to ut plus a half AT squared. Okay, so not difficult to see. Okay, if you like, I can write one more line here. Okay, T over 2, and I have 2U plus AT, then you can see it coming out. Okay, T over 2 multiplied by 2U, okay, will be UT, that's what you see here, and T over 2 times AT, you will have half AT squared. And we're done. Okay, let's continue writing here. From this formula here, we can also write T as equals to V minus U over A. Okay, writing T as the subject of the formula, we can just bring it up and bring the A down. We have V minus U over A. So now let's come back to our formula here, which is formula number 2. And now we will replace T with V minus U over A. So I can write, okay, T now I replaced that with V minus U over A, and the only reason I wrote this as V plus U is so that you can easily see I've got A plus B times A minus B, which is A squared minus B squared. So now I can write V squared minus U squared over 2A. So bringing the 2A up, I can write 2AS equals to V squared minus U squared. So let me write that again. This is V squared minus U squared, just cross multiplying. So now I can write my fourth formula, V squared equals to U squared plus 2AS. And we are done.